Good morning, students. Hope you are doing well. Welcome to Eclassopedia. Myself, Human, and I am Maths faculty on Eclassopedia. Eclassopedia is an e-learning platform where we teach all subjects from K to 12 international curriculum, including IGCSE, IB, EDEXEL, Singapore, US, UK, and other curriculum also. We also teach for competitive examinations like university examinations and other Olympiad examinations. We have the students more than 50 plus countries, including US, UK, and other Asian countries also. In this video, we will learn about a brief introduction of limit and continuity. So let's get straight to the video. So topic is limits and continuity. In this topic, we will cover definitions. That means we will cover the basic concepts. Okay. Evaluation of limits, how limit evolved, how we use it in our day-to-day life. Continuity. When we say a function is continuous, we also learn a basic concept about function. And then limit involving infinity. Okay, these are the topics that we cover. Look, question is, what is limit or why limit? Why limit? Look, when x is approaching towards a, first of all, understand the meaning of this statement. That x is approaching towards it, that means x is not equal to a. Okay, it is just approaching towards a. If we say x is approaching towards 2, that means x, the value of x we can take is 1.1.999999 in this way. It is not exactly equal to 2. This is called approaching. Okay, that means we are proceeding towards 2, but its value is not 2. Okay, in this figure or in this graph, you check that this graph is drawn in this way. Okay, at x equal to a, if we are approaching towards a, y is approaching towards L, the value L, okay, for this curve. So limit x tends to a, fx is equals to L. You can easily understand from this curve, okay. Okay, now let's understand by this an example. X minus 1 upon x square minus 1. If we factorize the denominator, what we get? We get x plus 1, x minus 1. And we can cancel this part. So what left? 1 over x plus 1. But the question is it correct? Is it correct to cut these two parts? I will say definitely yes, but x not be equal to 1. But what happens when x is equal to 1? If x is equal to 1, then just look at here. X minus 1 over x plus 1, x minus 1. If x is equal to 1, this value is 0 and this value is 0. We get 0 by 0, which is an indeterminate form. You know that this is an indeterminate form, and from here the existence of limit comes. That means we solve limit when we get indeterminate form. We are not getting the exact value. This is one of the most important part to understand. We get indeterminate form and we have to solve it. Okay. For example, let's take another example. X square minus 4 over x minus 2, suppose. Okay. So we can write it x plus 2. How? If you factorize, you will cut the denominator. But this is only equal when x is not equal to 2. Okay. Because when x is equal to 2, we get indeterminate form. Okay. So limit comes into existence when we get indeterminate form. These are the some examples that what happened or what will be the limiting value of these questions. Okay. Now, one question is that is it limit exist every time? Answer is no. Because look at here. If we draw a graph in this way, okay, that means the graph is broken. Suppose at x equal to a. So at this point, look at this point. At this point at x equal to a, if we approach towards this side and this side, we reach at a single point. Okay, so at this point we can say limit exists. Limit exists. Okay, but what happened when the graph is something like this? In this way, the graph is broken in interval. Then limit not exist. Limit not exist. The question is very simple, because if we approach from this side, we reach here, and if we approach from this side, we reach here. So we reach different point from both the directions. That means limit doesn't exist. So what it indicates, limit only exists, or we can find only the limiting value when we reach at a single point. Whether the function is continuous or discontinuous doesn't matter. Okay. But if we have a broken curve in a big interval or in an interval, then limit doesn't exist. Look at the graph. Suppose this is the graph first and this is the graph second. So what second graph indicates that we have a broken curve in this interval. That means limit doesn't exist. So limit does not exist when we have a broken curve in an interval. Okay, this is the important point that you have to answer. Just proceed. These are the questions that for x equal to 2, whether limit exists or not. That I already explained you. Let's proceed to next. Suppose someone asks, solve this or find the limit. Okay. So what we have to do? First, we will check whether we are getting indeterminate form or not. So put 2, we get 4, 4 minus 4, and 2 minus 2. That means 0 by 0. So we say yes, we are getting indeterminate form. So we get limiting value. That means limit exists. So whenever in any question you have to find the limit, you have to solve the limit, you have to check first whether it exists or not. For that, you have to check whether we are getting indeterminate form or not. Okay. Now put the value, or you can factorize. So x square minus 4 could be written as x plus 2x minus 2 over x minus 2. How? Very simple. A square minus b square is what? A plus b and a minus b. Okay. On the same basis, we just broke this part. Now we can cut x minus 2, x minus 2, and finally we get 4x plus 2. Now if we put 2, we get 4, 2 plus 2. That means 4 times 4, that means 16. Okay. So we are getting the limiting value. Okay. That means what it indicates? That it indicates what it indicates, that if curve is something like this, if we approach from this side or this side, we reach at the same point. Okay, this is the very simple definition of limit. Okay, hope you understand. If you like my video, if you like the content, you can subscribe, and if you feel any queries, you can ask in the comment section at any time. Okay? So what we learned in this video, we understand that limit exists when we get indeterminate form. and limit does not exist when we have a discontinuous function in an interval. Function is discontinuous in an interval. Function is discontinuous in an interval. Very simple. Okay. And third point that we learn that this is all about the function is continuous, the existence of limit, and function is discontinuous in an interval. And third point that we learn that if we have to solve any question or we have to find the limit, first we have to check whether we are getting indeterminate form or not, and after that we have to remove indeterminate form. How we can remove? Through factorization. This is the method by which we can remove it. Okay, and then just put the value, solve it. Put the value and solve. That's it. So these are the process. These are the basic concepts. How limit exists, why we need limit, and how we can say whether limit exists or not, and how to solve. So hope you understand up to here. If you want to contact details are given in the description box. You can check it. We are 24/7 available, so you can ask anytime. You can contact anytime freely. Okay. So students, that's it. So we will meet you next video. Bye.